I'm Christina Rogers, Senior Software Engineer in the LabVIEW R&D Group at National Instruments. In this video, I will be demonstrating the LabVIEW Notebook Pioneer, which is not a shipping product, but rather is something similar to what you'd find on NI Labs. The LabVIEW Notebook is a new file type in LabVIEW that provides easy management of your VIs, data, and measurement devices. When you create a notebook, LabVIEW opens a notebook editor. This single window editing environment provides everything you need to get up and running with LabVIEW. The primary and secondary panes show the front panel and block diagram of the VI you are currently editing. Click the secondary pane to swap the panel and diagram. The front panel of a VI is the user interface. To build it, you place controls and indicators on it. The most commonly used controls are in the palette. Let's build a VI to generate and display a random number. We'll place a vertical slider from the numeric palette for the maximum value. We can change its name in the configuration pane on the right. Then we'll drop a numeric indicator for the random value. The block diagram of a VI contains the graphical source code that defines the functionality of the VI. Let's place a multiply function from the numeric palette. Note that you can also search for functions by name by clicking the More Functions button. We'll place a random number generator in this way. When you mouse over a function, you can learn more about it using the Context Help pane in the lower right. The random number function generates a value between 0 and 1, so to get a random number between 0 and our maximum value, we need to use the multiply. LabVIEW is a data flow language. Data flows from one node to another on wires. Let's wire the inputs and outputs to the multiply and run the VI. To view the data flowing on the wires, we can use execution highlighting. We'll turn it on using this button in the toolbar, and then run the VI. See how a block diagram node executes when it receives all required inputs. It then produces output data and passes the data to the next node in the data flow path. Be sure to turn execution highlighting off when you are done with it, because it significantly slows the execution of the VI. Suppose we want to see a trend of values over time. Let's place a chart on the panel and wire the scaled random number to it. We can run the VI repeatedly, and the chart collects a history buffer to show past values. To make the VI run repeatedly until we press a stop button, we'll add a loop to the diagram. Everything inside the loop will repeat each time the loop executes. We'll use the configuration pane to add a stop button and check the user interface loop box to add a delay to each iteration of the loop so that we can control how fast values are generated. Now when we run the VI, we'll see a continuous stream of values. Note that the chart auto-scales the y-axis by default. We can turn this off using the configuration pane. To learn more about the LabVIEW Notebook, please watch the second video about using datasets.